quite what's going on that I find psychologically quite unsettling. And it's entirely possible that we will continue to observe the universe and not find anything, not quite know for certain whether we're alone or not. I think that the answer actually to the Fermi paradox is that we probably are alone, but it's not a solution, a resolution that I care for emotionally. Of course, the universe doesn't care what I think or what I care, but it is the solution that makes most sense to me. But it would be an eerie feeling, wouldn't it, that in all this immensity, it's us, it's just us rattling around.
Arthur C. Clarke once famously said that either we are alone in the universe or we are not, and both answers are equally disturbing. I actually find the proposition that we're alone particularly disturbing, even more so than discovering alien life, simply because we become an exception to the Copernican principle. All of a sudden, this planet becomes this magical place where organic chemistry of a certain flavor happens, and it happens nowhere else. And that disturbs me. I don't like uniqueness in the universe. I like repeatability.
So can I give you an example of a solution, if you like, to the paradox that came in quite recently? It was published 2020, so it's not in my book.
Absolutely.
And it's just an idea. I mean, it's not necessarily something to be taken for granted, but it gives you an idea of one possible reason why we might be alone, and why maybe the universe has to be as big as it is in order to contain us. So it's a piece of work published by a physicist called Tomonari Tatani. And Tatari says, we don't know how life started, okay? Well, we just don't. We don't know how we got from prebiotic chemistry to life. There's this assumption that the early universe had water, and it had this soup of chemicals, and there were these large gravitational tides and lots of energy going in with lightning and heat and the rest of it. And you cook this broth for tens of millions of years, and somehow you get life. And maybe that's the case. But what are the exact steps involved? We don't know. But one possibility is something called the RNA world, ribonucleic acid world. And RNA is important because it can store and replicate genetic information, like DNA, and that is one of the key definitions of life. And it can catalyze chemical reactions that we know are necessary for life, at least life as we know it. So it can play this double role. So the idea is that somehow you get RNA, and then from RNA, things evolve into more complex things like DNA and so on. Now, RNA is a polymer of nucleotides. Think of it as a chain of these blocks called nucleotides, and you need about 40, maybe 100 of these nucleotides in a chain in a particular order in order to have self-replication. Now, there might be some mechanism that polymerizes nucleotides to create this RNA, but we don't know what that mechanism would be, and as far as we know, it's just a stochastic random process, right? You're just adding, or nature is adding one nucleotide to another and seeing if they fit in just some random process. Now, if it is random, this turns out to be a combinatoric problem, and the chances of RNA just coming into being are astronomical. And actually, it's a lot worse than astronomical. Essentially, there's no chance of it happening in our observable universe of, 10 to the 22 stars. But Tatari says our best model of the cosmos suggests it came into being from an inflationary period. So you have this small patch of space-time, and that expands exponentially. You get exponential inflation. So our observable universe is just a small patch of a much bigger multiverse of very, very many other patches, perhaps similar to our own. We don't know for certain because it's beyond the horizon, but perhaps like ours. And Tatari said that in that multiverse of perhaps 10 to the 100 sun-like stars, you could, just from a random chance, get this abiogenesis. Now, not to take that too seriously, but it gives you an idea of how it could be just a chance event, but it's a chance event that leaves us unique, not only in this case in our observable universe, but in the multiverse. That is, to my mind, super spooky.
Would you characterize, having written a book on the solutions to the Fermi paradox, would you characterize the option that we are alone as the most terrifying?
Not necessarily. I think it's the most psychologically problematic solution, at least for me. But then if we go to this analogy of Halloween movies, on the one hand you have something like The Others, which is quite subtle. At the other end you have these mad axe murderer movies where some madman's going around chopping up teenagers. It doesn't appeal to me. But there are solutions where you assume that there are predators out there. And if you believe in the existence of extraterrestrial civilizations, then one possibility is that either there's predation going on, or civilizations keep quiet, we don't see them, because they fear that there might be predation going on. So that could be quite an unpleasant solution.
One of my favorite film franchises of all time, speaking of scary Halloween movies, is Alien. And is it possible that we simply assume too much about alien civilizations, and that maybe they are so different from us that we don't really know what to look for, because you can't exactly see a xenomorph, attacking people on a starship from a distance. You can't really see that. So is it possible that that we are just a very broad species in our abilities, and we emit a technosignature, as weak as it is? We emit radio and things that can be seen ostensibly at a distance. But could it just simply be that most intelligent life in the universe is in the form of things like the alien?
Absolutely. And we always have to be on our guard against this anthropomorphizing in general. So I mentioned the predator interpretation. I mean, it goes back to Fred Saberhagen with Berserkers, and more recently The Dark Forest of Cixin Liu. But they're predicated on this idea that alien civilizations would have the same motivations as us, that they'd take this first strike approach because they assume everyone else will take that first strike approach, seek out new life, new civilizations, and kill it. That might be a very, very parochial attitude. And it's very difficult, I think, to free our minds of the attitudes that have developed within us. I mean, we are creatures that have evolved on a certain planet with a certain environment, and it's given us certain predispositions which we have to have in order to survive and pass on our DNA. Out there, those civilizations, as I say, with whom we would share nothing but prebiotic chemistry, who knows what evolutionary pathways would have taken them down. So I think you're right that we can't or shouldn't assume things about extraterrestrial civilizations, except that I think they have to obey the laws of physics as we currently understand them. They may have a much more evolved understanding of physics, but I think it's important when we're discussing these things to stick to what we know. Otherwise, it's a little bit like playing tennis with the net down. There's no rules. You can imagine anything. So I think we have to restrict ourselves to assuming that alien beings, if they exist, obey the laws of physics as we understand them. Probably they have to obey laws of economics. But other than that, I think you're right. We have to try and be as non-parochial as we can possibly be. And it's difficult.
Is that a solution to the Fermi paradox, though, that alien civilizations are simply not as broad as we are, and that they just never get to the level of detectability simply because they're not equipped to? So they may be bound in oceans as aquatic life, or something stops them from getting to our level, and that it's simply that the solution is that we got lucky being bipedal mammals.
Well, of course. I mean, if you think of what it is that we're talking about in terms of making our presence felt across the universe, disturbing the universe in a way that another being can detect. So we're talking about, first of all, being terrestrial creatures, because you're quite right. You can imagine aquatic creatures, super intelligent. They're not going to make their presence known. Dolphins, I don't know how intelligent they are. Octopuses seem to be very intelligent. However intelligent they are not going to make their presence felt across the universe. So it's a terrestrial civilization. You need that civilization to take, or you need that intelligence to happen on a planet where there is raw materials for the development of technology. Okay, if you don't have access to energy dense material, it's difficult to see what it is that you can do in terms of developing a civilization. The act of reaching out across interstellar space presumably is not an act that can happen with an individual member, an individual creature. We're talking about social creatures, presumably, because this would have to be an act of a group, a civilization reaching out across space. So that implies social groupings. It implies communication skills, sophisticated grammar in order to agree among the groupings that this is something that we're going to devote time and effort and resource towards doing. And it requires that level of intelligence. I mean, why? We think we are atop some level of evolutionary ladder. We're really not. I mean, we're just one tiny twig on this branch of evolution. But we do have a highly developed level of intelligence. Why do we have that? I mean, what evolutionary benefit does the ability to do integral calculus afford us? Now it gives us access to technology, but how did that evolve? Is it just some sort of accidental byproduct? So I would argue that we are actually incredibly special, but so is every other creature that has evolved on this planet for the past billion years. It's just that our particular constellation of qualities, that idea of social grouping and complex grammar and high level of intelligence, that set of qualities that define us, they happen to be the set of qualities that enable us, perhaps, if we survive, to make our presence felt across the universe. And it's those sorts of qualities that presumably some alien creatures would have to have if they were going to reach out across the universe. Of course, a depressing thought is that maybe all of this constellation of qualities, intelligence plus opposable thumbs, maybe that's a bad long-term evolutionary strategy. Maybe intelligence plus opposable thumbs equals disaster. I mean, that's another depressing resolution of the Fermi paradox.
Yes, and that civilizations, once they arise, they quickly burn out, and we sort of look like that a little bit at this point. Now, could it be, as far as odds of celestial bodies producing alien life, Could it be, based on our solar system, where we have a whole bunch of candidates for ice shell moons, oceans underneath ice, could it be that the universe is largely aquatic and that the best we can ever hope for as far as an alien contact signal to us is a plea for help and an ask for uplifting because they're stuck in an ocean and we aren't? Does that have legs?
I don't think they would be able to make that connection. I don't think they would know of the external world necessarily. It would be fascinating if we could communicate with an octopus or a dolphin and try and understand what it is that they perceive of the world and what they understand of the world. But I suspect that they would have zero understanding of the cosmos and zero ability to make their presence felt. What you mentioned about ice worlds and oceans in the solar system in particular, I think that's fascinating. On a very short time scale, we might be able to find out whether abiogenesis is actually not as rare as I suggested it might have been. Maybe we get to Mars and we analyze samples and we discover that Mars was once home to life that arose independently of life on Earth. Or we go to Enceladus or some of the other moons and discover that life began there. That would be an absolutely amazing discovery if we find that. It then suggests that abiogenesis isn't that incredibly rare thing that Tatari said it might be, but it's actually very common. If we find that, though, if we do discover that, it really suggests that the answer to the Fermi paradox is not necessarily something that's beneficial for us. It perhaps means that the reason we don't see advanced civilizations, even though there really should be because there's all this life out there, it's because, for whatever reason, either a hostile universe or the fact that intelligent species inevitably bring about their own destruction. I think it brings that much more to the fore as a potential solution. So part of me hopes that we don't find life on Mars or Enceladus or these other worlds.
That gets into questions of panspermia and our own origins. We could actually be aliens to this world if life arose on Mars and was deposited here very early after the late heavy bombardment or during it. But my question to you is this. Okay, so we have all these missions and we're thinking of even more in the future to go and investigate the possibility of abiogenesis in ice shell moons and on Mars and Venus for that matter. If we find that and we actually find a second genesis of life within our own solar system, does that for you solve the Fermi paradox? And you can safely say they must be everywhere in various forms, maybe not as complex as we are, but maybe we're rare, but life itself is not. Does that solve the Fermi paradox for you?
No, it actually makes it a lot stronger. What that discovery, I think, if it happens, what that discovery would allow us to conclude is that life itself, the creation of life itself, is a common occurrence, because we would have multiple examples in one solar system. We can, I think, safely assume that other solar systems, other exoplanetary systems, would then, adopting that Copernican principle, would then have lots of at least low-grade life. It would begin to address the question about the role that biology plays in the universe, and it would enable us perhaps then to go out and start thinking about the characterization of exoplanetary atmospheres and look for the presence perhaps of low-grade life affecting exoplanetary atmospheres. But if the universe really is teeming with low-grade life, Why then, seemingly, has that evolutionary process towards extraterrestrial civilizations not seemingly taken place? So I think it would actually strengthen the paradox. And I've changed my thinking considerably over the past few years around this. I used to think that maybe the universe was full of, some sort of pond scum and low-grade life. And I still think it's possible, but the only way out of the Fermi paradox that I can see in that case, other than that there's a barrier ahead of us that somehow intelligence dies out, is that the jump from, if you like, single-celled creatures to multicellular organisms, perhaps that's the jump that's difficult. And I think that's what we would have to hope is the case, that getting from simple unicellular life to complex multicellular life, maybe that's the difficult jump, and maybe that's what makes us special here on Earth.
That took Earth like something on the order of 1.8 billion years to do that, right? So that's a strong, great filter.
Presumably. And it's difficult to know what happened, given that it happened a long time ago, but presumably one cell ingested another for food, and for whatever reason, those two cells coexisted, or maybe one cell infected another, and rather than the infection killing the first cell again, some sort of symbiotic relationship took place. It's difficult to know what happened, but maybe that is something that is unlikely to happen. And certainly on Earth, that long stretch of time that you mentioned perhaps indicates that it is a barrier to jump. Yeah.
That is actually a really fascinating thought, that the development of symbiosis between organisms, which we see on this planet. There are examples, for example, beans, where they carry a beneficial nitrogen-fixing bacteria with them in their seeds and infect the soil with it so that they can fix nitrogen from the atmosphere. And that's an interesting idea, because it simply says that the solution of the Fermi paradox is that everything is microbial until it chemically reaches a point where it can actually exist symbiotically with another organism. But that also seems to open up a rather scary door, because when you have symbiosis like that, doesn't that increase the chances, increase the complexity, and the possibility of extinction?
It absolutely does. And it's another example where really to understand ourselves and our history, I think astrobiology can play potentially a really important role. And I don't think we're going to find the answers to these questions in the next 2, 3, 4, 5 years. But I really am hopeful that with things like the Extremely Large Telescope coming, possibly even Webb, certainly with the successors to Webb, that we might be able to start reaching out, studying exoplanets, and maybe getting a handle on these sorts of questions. I realise that so far I've been saying that, well, my preferred solution is that we're alone, and we've looked at solutions that suggest that we might be alone, or at least that we're the only intelligent species. I have to say, a lot of people would argue that actually there is no Fermi paradox, because they are here. You mentioned panspermia. One possibility is directed panspermia, so that the origin of life here on Earth came about because we were deliberately seeded by some other alien beings. And that idea that aliens are here, or were here, I mean, that stretches right the way through to UAP, the modern UAP phenomena, zoo hypothesis, planetarium hypothesis. So just for the sake of completeness, I have to say that actually possibly the most popular resolution of the Fermi paradox is that actually there isn't one, they're here.
Now, we, of course, live in a world where a great many people believe they're here and people see things. And I, for one, don't doubt that people see things that they can't explain. I absolutely believe that people see UFOs. The question is, what is their origin and what are they? Do you think, based on the evidence that we have, and we have these things like congressional hearings in the US here and things like that that are looking into the long history of ufology, do you think that that has legs? As a scientist, can you look at what we know based on that and say, this is worth looking into? Or, no, nothing here?
So I would say, no, there's nothing there. If you are arguing that these are alien craft, okay, there's clearly something there. But I think it's important not to prejudge any of this, and this is where I have some issues with what's happening at present. So clearly there are UFOs, clearly there are, to use the more modern terminology, UAPs, unidentified aerial phenomena. That's just, it's a given, it's clear. There are records of them. What are they? Well, if we're going to investigate that question scientifically, that's fine. And I'd argue actually that we have to, for safety reasons, because if these things are happening around military jets, there's the possibility of dreadful things happening. If it's happening around just commercial air flights, accidents might happen. So absolutely they need to be investigated. But why on earth would you go to astronomers as the first point of call for investigating these? It's almost as if you're saying that I know what these UAPs are. I've identified them. They're craft. They're alien craft. No, we don't know that. I think the people that need to be involved first in this identification and this research about trying to identify them are software engineers, optical physicists, psychologists, aeronautical engineers. There's a dozen specialities that I think should be brought to bear before you even think about bringing astronomers into the discussion, because frankly the skill set of astronomers is not something that's particularly going to help, I wouldn't have thought, with this particular problem.
Well, that's always been the question, because everybody always looks to the astronomers because public perception, they're the ones that look at the skies. But the thing is that they typically only look at a very tiny part of the sky and would miss the UFO if it flew by. And it's just not their bag. But what I wonder is if the best specialized scientists would be the atmospheric scientists, because
absolutely
there's some weird stuff that happens in the atmosphere of this planet as far as plasmas and things like that go, that an astronomer wouldn't really, that's not what they do. So we should be asking the atmospheric scientists, right?
Absolutely. That would be personally my first port of call. If I can just, you just popped something into my head which illustrates, I think, something potentially about the Fermi paradox, but also about the skill sets of different scientists. There was a gamma ray burst detected a few weeks ago. I can even remember what the name of it is, because I know the dates when it was found. It's GRB 221009A, and this is the brightest gamma ray burst ever detected. Now, this is a Fermi paradox solution, because if you're anywhere near a gamma ray burst, you're toast. What's fascinating about this one is that it's about 2 billion light years away. I mean, quite a distance. And yet atmospheric scientists, and this is what you said that just popped into my mind, atmospheric scientists detected it. It affected the way that radio waves propagated in Earth's atmosphere from a distance of 2 billion light years. I find it absolutely incredible that the universe can impact on Earth from that distance, but it can. And it was atmospheric scientists that noticed that impact. I don't think astronomers particularly would have thought about that. They were interested in, it was Fermi Space Satellite that detected it, and various other gamma ray and X-ray telescopes. Incredibly bright event, incredibly violent event, and actually a nice example of astronomers and atmospheric scientists working in tandem, but they were looking at very different things.
But it's still the universe. So anything that you observe is an aspect of the universe, so they kind of mesh together. Do you think that interdisciplinary science is a disadvantage? In other words, do you think people are too specialized and don't come together enough for a complete understanding of the universe? Do you think that crossing the aisle between sciences, we need more of that?
Oh, absolutely. And this is one of the fascinating aspects of this question for me, the Fermi question. I find it fascinating because physicists have a take on it. Well, of course we do, because we're arrogant and we have a take on everything. But astronomers have something to say about it. Biologists have something to say about it. I've seen lots of interesting papers from historians and sociologists. This is a question that can bring so many people together with so many different insights, and we can learn from each other, and that's one of the beauties, I think, of an interdisciplinary question like this. The problem we have is institutionally, it can be difficult to bring these people together. There are relatively few mechanisms for doing that. And it is still the case that